Okay, in this program, we are going to be creating a vector, and it's going to be randomly generated, and we'll be removing all of the odd numbers from the vector. So to get this started, we're going to need to include our vector object. We are going to include the time library. And because we're dealing with random numbers, we'll of course start with our randomization line. So srand time null. Okay. So in this one, we're going to have two vectors, and they'll both be identical. So we'll have vector int numbers, and then vector int numbers 2. So both of those are going to be the same. And then we're going to be keeping track of the cost of our program. Now, the cost is usually, when we're writing a program, one of two things. So the cost is either the speed of the program, so how much time it takes to run is a cost. The second cost is commonly the storage of the program. Some algorithms are really fast, but they take up a lot of storage, and some of them are a little bit slower, but they take up less. So sometimes it's a trade-off. In this program, we are going to be using a fictional cost of the erase function that we're going to be using. Every time we use it, it's going to cost us $10. So that's a fictional cost, but it'll simulate some of the ideas that are pretty important from this one. Okay. So now what we're going to do is we're randomly going to generate the content of numbers. So for int I equals 1, while I is less than 20, we'll put 20 numbers in this, I plus plus. Then we're going to do a numbers dot pushback. So we're going to be adding random numbers to the end, and they will be random number modulus 10 plus 1. So just numbers from 1 to 10 in this scenario. And then what we'll do is we'll display the numbers that we've got. So before we display it, let's store it. So numbers 2 is going to become numbers. There's no numbering on that one. Okay, so we'll just have it as a backup there for later purpose. So now let's do the display. So for int display is 0, while display is less than numbers dot size, and display plus plus. We're going to see out numbers display, and then we'll separate them by a space, and then when we're done the whole thing, we'll do an end out. So let's see what we've got first. Well, where did I put numbers? Here we go. Okay, so what we've got our 20 values. We'll be removing the 3, the 3, the 5, the 7. So it's actually going to make the final result shorter than the original, unless the random off chance that there ends up not being any odd numbers in it. Okay, so now let's make our cost become 0. So we'll set it to 0, and then we'll start our loop. So we need a loop that's going to traverse the array. So for int I equals 0, I is less than numbers dot size, I plus plus. So now we have to make a check to see, is the number random? So if numbers I modulus 2 equals 1, then we know that it is this is our check for to see if it is an odd number. If it is, what we'll do is we will erase that number. So numbers dot erase, and then we're going to refer to the position that we're currently in. So we're going to be using the numbers.begin pointer. So numbers.begin points to the beginning, and then we have to advance it by I positions because that's the number that we're looking at right now. So it's going to find the position that we're on and erase it. And then the cost is going to be cost plus 10. And then what we'll do is we will display it. So I'm going to do a little copy paste here, grab this, and then I'm just going to do some appropriate tabbing. So every time we erase, we're going to get another look at what our values look like. So let's play it. And there's an error in here, and we'll need to show you what the error is. Okay. So in this situation, we get the 5, and it gets eliminated. Now, the next one that should be eliminated is the 5, but you'll find that it actually moves back to the first position, and the 5 ends up not being the next number that is eliminated. The next one that's eliminated is the 7, and you can see that the 5 is left the whole time. So here's what's happening. I is 0, it erases this position. Then when the loop goes back to the beginning and hits the I++, then I becomes 1 on the second round. So it realizes this is an odd number, so it removes it, and then I becomes 3. We'll see the same thing in just a second. Then, 0, 1, 2, it becomes 2, then it becomes 3. Sorry, it should be 3 here, right? It'll remove the 3 and then move on, but it's already moved past the 7. So every time we remove a number, we have to shift I backwards so that it looks at the position again. What I needed to do is look at the 3, and then the next time I need it to look at the same position instead of the next one. So every time it erases, what we want to do is we want to put in an I minus minus. And we'll make sure that this works. Okay, so in this scenario, we get a 3, and then it goes back to 0, and then it eliminates the 5. We get a 10, and then it gets to kind of go on its way. Let's display what the cost is before we make an adjustment to it. So cout cost. There we go. So you can see that it took 12 erases to get rid of all of the odd numbers at a cost of $120. Now I want to bring this down as much as possible, so I am going to use the erase function where I can say arrange. So imagine that I get to here. I don't want to use the erase function 4 times. I want to use it once to get rid of all 4 of these. So that's what's going to happen in the second version here. So let's try this again. What we're going to need is we need a beginning and an end of the range. So we're going to call those erase 1 and erase 2. And we're going to have to set the cost to 0 again so that we can make a comparison. Now, same thing, we're going to keep a for loop here. So int I equals 0, well, I is less than. Now, before you go ahead and make a copy paste error, this is numbers2.size, not numbers without the number after it. Okay, now, similar thing, we're going to have to check to see, is the number that we're looking at an odd number? So we're going to use the same method as before. So if numbers I modulus 2 equals 1, then we are going to launch into our erase plan. So what we're going to do is we're going to set erase 1 to become equal to I. So the beginning of our region that we will be erasing is centered on the start position. Now, what I'm also going to do is I'm going to have erase2 become I, because you need a range, and if there's only one number, they both need to be that same position. Okay, now what I have to do is I have to find the end of the odd number section. So if we get 5 in a row, I need to figure out where the end of that 5 in a row is. So for that, we have to use a second loop. So for int, we're going to be using j as the counter for this. And we're going to start it as being equal to I. So we're going to start where we found our odd number, and then move down the line until we find something that's even. Okay, we're going to go while j is less than numbers 2 dot size j plus plus. Now if we find an even number, so if numbers 2 modulus numbers 2 j modulus 2 equals 0, then we know we found an even number. So we're going to break out of this loop. So this is our even number. Otherwise, we're going to have erase2 become equal to j. So what's going to happen is erase2 is just going to keep going up by one position, by one position, by one position, until it eventually breaks because it found an even number or it reaches the end of the array. Okay. So now, considering that we did some erasing, we'll use our erase line. So numbers 2 dot erase numbers 2 dot begin plus erase 1, that's the beginning of the region, to numbers 2 dot begin plus erase 2, but we also have to do plus 1, because if I don't do that and I want to get rid of position 3, 4, and 5, this will be 3, this will be 5, but it'll only get rid of position 3 or 4 because this one is not included in the erase. So we actually have to go to the next position just to make sure that it is included. So every time we do this, we're going to have to, of course, increase the cost. And make I minus minus because we want to back up and make sure. Although we will not really be experiencing that to the same degree with this. Now, what we're going to do is then display it. So we've got to, if we're copying and pasting, we do have to make an adjustment here though, that this will have to be based on the numbers 2 vector. That's going to be important. And then we'll see out and out. Okay, last thing I'm going to do is display the cost, which I'll do as a copy and paste. Okay, now I feel like I've got an error here, so I'm just going to verify. We'll see what we get. Oh, okay. So here we go. We got to check to see if numbers 2. We'll see if I made that error anywhere else. That's an easy one to make. There we go. Okay, so here I've got my 2 arrays. They're identical. However, you can see that the cost of the second one is lower because I'm using the range erase as opposed to the individual erase. So we got 3, 9. What's going to happen down here is instead of doing them one at a time, they both get erased at once. And then it'll do that for any of the other situations as well. So that's a little example of using erase and also how the efficiency can change between using one versus the other.